Last time we started 9.2, Multistage Experiments, and we had taken a look at a few examples so far. And we talked about tree diagrams. The last example we left off on was an example where we had some spinners. I think there's one more after that, didn't we? Yeah. Where we were saying, we were talking about the fact that we don't always have to have the same number of branches off of each branch. That's actually a possibility depending on the context of the problem. We're going to do another example after this one, a couple of them, that are going to relate to something that's maybe a little bit more real life kind of things. The first one we're going to talk about is Joe. And this is kind of along the idea, or along the lines of the idea of, I don't remember the name of the person, but the person in the last section who had the basketball, right? It's 50-50 shot, and it's not really like that. So Joe's kind of thinking along those same lines. So Joe says that if a family has 2 children, then the only possibilities are 2 boys, 2 girls, or 1 of each. So far, is he right? Yeah, he's right. I mean, if you've only got 2 children, it's one of those 3 things. Because there are only 3 possibilities, he believes that the probability of having 2 boys is 1/3. The question is Joe correct? This has the same feel to it as the basketball example. There's only 2 things that can happen, so it's 50-50. There's only 3 things that can happen, so it's 1/3, 1/3, 1/3. But is it really? No, it's actually not. And I'll draw a tree diagram to show it, and then I'll show you another way you can think about it too. So one thing that you could think about is you can think about actually what happens when you have a child physically. So you have a child, and when you have a child, you only have one at a time. Even if you have twins, they only come out one at a time. So this is sort of child number 1, the oldest child person, okay? There's only 2 possibilities, right? Oldest child can either be a boy or a girl. So we've got a boy, we've got a girl. So this branch of the tree is child number 1. After you have child number 1, you have child number 2, so we have another set of branches off my tree. And that child, it is boy or girl each time as well, right? So boy or girl, boy or girl. Now, let's go back to the original set of branches, boy or girl. What are the probabilities along those branches? They are. They're 1/2. And along the second set of branches? Yeah, they're all 1/2s as well. So the branch of the tree that Joe's talking about is this branch right here, right? The branch that's boy, boy. What is the likelihood of that happening? It's 1/4. Why? Yeah. I want to make, the reason I'm asking the why again is because I want to make sure that you're doing this as a multiplication. It's 1/2 times 1/2. It's not because there's 1 out of 4 choices at the ending branches. Now that works on this one because all the probabilities were 1/2 and equally the same. That doesn't work on every problem. Yeah, so there's actually a 1 out of 4 chance. So what are we going to say to him? I mean, this is an argument like in terms of a diagram that explains something. But anytime, and this happens on your tests all the time, I use the word explain. What does the word explain mean? Words. It means you're going to write something out in words. So let's talk about what you might be writing down, and then I'll let you choose what you want to write down in response to Joe. What are some things you might tell Joe?
That he's right, that it can either be 2 boys, 2 girls, or 1 of each.
Good. I like that, Tristan, because I think it's a good idea when you're working with your students to tell them what they did right, especially starting out that way. It feels a lot better than somebody correcting you off the bat, doesn't it? Yeah, so I think that's good. What else? We can't stop there, agreed?
However, explain that there's 4 different ways, or 4 different orders that it can order.
Okay, so we could talk about the ordering. So even though there's a possibility of having a boy and a girl, we could have boy older or we could have girl older, which actually makes 2 different orderings of the children, right? That's a very good description of what's happening. Is he's sort of forgetting this sort of an idea of ordering of the children, right? Another way, if you didn't want to use a tree diagram in particular to talk to Joe, is that you could actually write down the possibilities in sort of an ordered pair format. We could do boy-girl, we can do boy-boy, we can do girl-girl, or we can do girl-boy. So there really are 4 different ordered possibilities, like you mentioned, and we could talk about it in that way, in terms of the different options here. So write yourself down in the space over to the side with all the lines, write yourself down something that you might tell Joe to explain what's going on. Okay?
tree diagram, like, and like there might be different parts of it, but just one tree diagram?
Yes.
Okay.
Yeah, you don't need, if the situation or the context hasn't changed, you'll actually see an example of that here in a minute where I'm going to do something very similar to what you're asking.
Okay.
If the situation or context doesn't change anything, then there's no reason to redraw something.
Okay.
Mm-hmm. All right, you guys pretty much ready to go to the next one? Everybody done writing your response to Joe? All right. I'll tell you a little bit about my family today. Huntington's disease. Is anyone familiar with Huntington's disease? You heard of it before? Brianna, Cassie. Okay, so we've got two of you who are familiar with it. Huntington's disease runs my family. My grandmother had Huntington's disease. She died in 2000. Same as the year before that Abby was born, so 2005. And then my father had Huntington's disease, and he passed away just about a month ago now. Huntington's disease is a little bit like Parkinson's disease. Familiar at all with that? It affects your central nervous system, so it starts making certain parts of your central nervous system shut down. And it does it by overproducing an enzyme. So it produces too much of something that your body can't get rid of. And so it gets in the way of your brain telling your body how to work right. So one of the specific instances that I remember from my grandmother was going to a place like a Golden Corral where they have a soft serve ice cream where you serve it yourself. And she couldn't make her hand stop in time, and there's ice cream everywhere because it took too long for her brain to tell her hand to stop. It did, it just took too long. And so eventually it affects other things. It affects your balance. My father was notorious toward the end of walking all hunched over. So that was something that my son will always remember about my dad, is that he walked kind of hunched to try to keep his balance. My grandmother didn't do that, and as a result, she fell a lot because she didn't try and compensate for that. It's an absolutely horrible disease. And if your parent has it, then every child, biological child of that parent, has a 50-50 shot of having the disease. And I mean, it's exactly 50-50. There's nothing about it. I will tell you that I went to a Huntington's conference when I was living in Ohio, and we met a family there, and it was the same thing. They had 50-50 shot. And this poor woman had something like 13 grandkids, and all of them had it. All of them. It's 50-50 shot, but it hit every single one of her grandchildren. So in 2001, my parents decided to have a family meeting and share with us that this is what my grandmother had. And the reason that they shared with us was not because they felt like it's time you should know, which would have been an appropriate response or something. But they shared with us because with new innovations in science, it's possible to have a child. If you had it, it's possible to have a child and to avoid having this genetic disease. It's basically done through in vitro fertilization. It's being selective about the embryo that they implant in the mother's womb. My husband and I decided that that wasn't okay with us. We weren't okay with that idea because it felt too much like playing God. Basically, at the point when they would decide that the embryo had Huntington's disease, they would be destroying it, and we weren't okay with it. So the evening that they told us this, I was married. I'd been married for almost 3 years. My sister was married for almost 1 year at that point, and my brother was seriously dating the girl that he is married to now. They've been married for quite a few years, but at the time they were just dating. So we were actually visiting. We were living in Kansas, and we were visiting my parents' house, so we're staying overnight there. And I remember specifically being in the bedroom, and my husband and I just talking and going, what are we going to do with this information? What am I supposed to do with this? And feeling a little betrayed by my parents because I felt like my husband had a right to know this before he married me. Not that he wouldn't have married me, he would have, but he had a right to know what he was sort of getting himself into because my parents knew something that they didn't share. And at that moment, we decided, even that night, that if I had Huntington's disease, we would not have children. That was it. We weren't having kids. And so what I want to show you is kind of what went through my mind. I didn't draw a tree diagram in my mind, but I did all of these kind of probabilities in my mind that night, after kind of having my whole world shaken up by my parents. So I have 2 siblings, and I'm actually the oldest one. So this first tree branch is actually me. I'm the oldest, so that's where we're going to put me first. And along this tree branch, there's 2 possibilities. I either have it or I don't. So I'm going to write HD for Huntington's disease on this one and just write don't on this one. So either have it or I don't. And it actually is a 50-50. So I'm going to do decimals because I haven't done decimals on one. On the last one I did fractions, so I'll write in decimal form. You're going to do a problem in your homework that's going to be like this, but they don't have 50s everywhere, the 0.5s. They have a 30% chance. I think it's a problem it's a genetic disease problem as well like this one, but it's a 30-70 chance. So just because I'm drawing two branches is not why I'm putting 50-50. I'm putting 50-50 because that's how this particular disease progresses. Okay, is everybody clear on that fact? All right, so after me is my sister. So those next branches represent my sister. So it is a completely independent event. There's absolutely nothing that says that if I have it, she does or doesn't, anything like that. And so, you know, we write the same branches out, kind of like we did with the boy-girl diagram before. And they're all 50-50 as well, because it's a 50-50 chance. And then I have a second sibling. There's a third one of us. It's my brother. And he either has it or he doesn't. So this is the first time I've presented this information since my dad passed away. It's a little different. This is the 6th time I've shared this with a classroom, and it's pretty personal. Huntington's is a really scary thing, and those who have studied it sort of in the science field or whatever, nursing and whatnot, and I say there's Huntington's in my family, I get gasps. It's really bad. So this kind of an image is basically what I did, but without the imagery of it in my mind that night. And I did the next question that you have. The first question was the question that I did in my mind when this happened. The question that we're going to look at first, part A, is what is the probability that at least one of us has the disease? Okay? So what I'm going to do is I'm going to write that down. And we talked a little bit about this kind of a description last time, but we didn't see a problem where it had to be used in this way. So if you take a look back at your diagram, and it's just right above on your paper, and you go along every branch, and you look at every branch that includes one of us of the three having Huntington's disease, it's nearly all the branches, right? There's only one branch that doesn't have that happen. It's the last branch. This last branch right down here is the only place where at least one of us doesn't have Huntington's disease. So instead of calculating 1, 2, 3, 4, 5, 6, 7 probabilities and then adding them up, what I can do is I can use that complements theorem that we talked about last time to say that this is 1 minus the probability that none of us has it. You can calculate it either way, but this is the simplest way to do it. Okay? So this is 1 minus. Now take a look at that last line of probability. What is the probability, or how would you find the probability that none of us has Huntington's? What would you do? Right. You're going to multiply along that final branch, the branch where none of us has it, and you're going to multiply those together, and then you're going to subtract that from the number 1. What do you get? For the multiplication, right? So what do you get for the subtraction then?
0.875.
It's very close to 90% right there. There's an 87.5% chance that my family will deal with this disease for another generation. That myself, my brother, my sister, that one of us at least will have Huntington's disease. And that's a really scary number. It's really scary. The only reason my family told us about Huntington's at the time was because of in vitro fertilization and that possibility. And they really weren't braced for what my husband and I were to decide, was that we weren't having kids. We made the conscious decision that we were going to be parents. We just weren't going to allow this to rule the rest of our family line. And so in 2000, And 3, I was tested for Huntington's disease, and I do not have Huntington's disease. The reason that I have my daughter Abby, my only biological daughter, is because I don't have Huntington's disease. Because if I had it, we wouldn't have had her. Wouldn't have happened. However, what I always like to tell people is that God can use anything in your families for good. Because I'm fully convinced that the reason that I have my son, and now the 2 more that are joining our family, is because of this. Because Huntington's disease runs in my family, my husband and I made the decision that we were going to look into adoption. And before I was even tested, if you take a look, there was a 2-year time span between when my family told us about Huntington's and when I was tested. 2 years that God worked on us. And he made it very clear to us that regardless of how that test result came out, he wanted us to adopt. It was very clear. And so, because I had to go through that, we made the decision before it ever came down to fertility or anything like that, that this was part of God's plan for our family. So I don't have Huntington's, which means that this diagram over here that we created is in this piece of it. We're down here. Because I don't have it, which means this branch doesn't even apply anymore up here. So if we take a look at the next question, don't scratch yours out, please. I just scratched mine out. Don't scratch it out. If you take a look at this next question, it wants to know about the probability of my siblings' situation, because at this point, neither of my siblings have been tested for Huntington's. And we still have, this branch, if you will, of our diagram going on with all the 0.5s in there. Everything is exactly the way it was before, but it's just a 2-branch diagram because there's only 2 people that are, not checked out at this point. So if you look at the same question and you ask the same question but with respect to this diagram instead of the other one, we can do the same thing. We can talk about this being 1 minus the probability that no one does. And along this diagram, we can take a look at the don't, right? They don't have it. And we can find that value as being 0.5 times 0.5. And if we calculate this, what is the final probability that at least one of my siblings has Huntington's disease? And then 1 minus that. Mm-hmm. So 0.75, right, Allison? Yeah. So 0.75 is the probability. There is still a 75% chance that at least one of my siblings has Huntington's disease.